Question 9. The amount of an antibiotic in the bloodstream from a given dose is modelled by the formula x equals d e to the power of minus 0.2t, where x is the amount of the antibiotic in the bloodstream in milligrams, d is the dose given in milligrams, and t is the time in hours after the antibiotic has been given. A first dose of 15 milligrams of the antibiotic is given. Part A says, use the model to find the amount of the antibiotic in the bloodstream 4 hours after the dose is given. Give your answer in milligrams to 3 decimal places. So we're given that the dose is 15 milligrams, so this is our D, and we want to know the amount of antibiotic in the bloodstream 4 hours after the dose has been given. So this is our value of T. So all we do is substitute these values into this. So x equals 15 times e to the power of minus 0.2 times 4, which is 6.740 to 3 decimal places. A second dose of 15 milligrams is given 5 hours after the first dose has been given. Using the same model for the second dose, Part B says show that the total amount of antibiotic in the bloodstream 2 hours after the second dose is given is 13.754 milligrams to 3 decimal places. The second dosage has been given 5 hours after the first, and we're trying to find out the amount of antibiotic in the bloodstream 2 hours after the second dosage. So that's been a total of 5 plus 2 hours, so 7 hours since the first dosage. So to find that, we would need to use 15 e to the power of minus 0.2 times 7, because it's been 7 hours since the first dosage has been given. And the amount of antibiotic in the bloodstream from the second dosage, we're going to treat T as 2, because it's only been 2 hours since that second dosage has been given, and 7 hours since the first dosage. Working these out and adding them together gives 13.754 to 3 decimal places. No more doses of the antibiotic are given. At time t hours after the second dose is given, the total amount of the antibiotic in the bloodstream is 7.5 milligrams. Part C says, show that t equals a ln of b plus b over e, where a and b are integers, so whole numbers, to be determined. For part B, the reason why we use 7 here is because the total amount 2 hours after the second dose is given, so altogether the first dose has been there for 7 hours, it's been 5 plus the 2. If the question was 3 hours after the second dose, it would have been 5 plus 3, so we would have 8 here. Or if it was 4 hours after the second dose, it would be 5 plus 4 to give us a 9. Part C generalizes that. So instead of having 2, 3 or 4 hours after the second dose, we're looking for t hours after the second dose. So the first term we can write as 15 e to the minus 0.2 times 5 plus t. 5 because the second dose was given 5 hours after the first, and t, it's t hours after the second dose. This term here, it's the amount that the second dose is in the bloodstream. If we're looking at t hours after the second dose, then instead of a 2, we're going to use a t. So we have 15 e to the minus 0.2 times t, and this we're told it's equal to 7.5 milligrams. So we can divide both sides by 15 to get e to the minus 0.2 times 5 plus t, plus e to the minus 0.2 times t equals a half. Expanding out the brackets, minus 0.2 times 5 is minus 1, and minus 0.2 times t is minus 0.2t. Remembering the rules of indices that states x to the power of m times x to the power of n equals x to the power of m plus n. So if the base numbers are the same, we can add the index numbers. If we assume that the base number is an e, then we can use this rule going backwards to split this up to get e to the minus 1 times e to the minus 0.2t. Now we can see that we have e to the minus 0.2t, that's common to both, so we can take it out as a factor. And in the bracket we will have e to the minus 1 plus 1, because e to the minus 0.2t times 1 stays as e to the minus 0.2t. We can divide by this whole bracket So it will be 1 over 2 times this bracket. Taking the logs of both sides, so we'll have ln e to the minus 0.2t equals ln of this whole thing. Remember, 1 over x equals x to the minus 1, and if we treat this whole thing as one term, we can bring it to the top to get ln of 2 times e to the minus 1 plus 1, all to the power of minus 1. Remember, in the rules of logs, that states ln x to the k, where we can bring the k down to the front to equal k ln x. Here we can bring this down to the front to get minus 0.2t ln e to the 1. And with this we can bring the minus 1 down to the front to get minus ln 2 e to the minus 1 plus 1. The minuses cancel out, and ln e to the 1, the ln and e's cancel out to just give 1. 0.2t equals ln of 2 times e to the minus 1 plus 1. We're almost there. So if we look at this part here, e to the minus 1 plus 1, well, using what we've just written here, is the same as 1 over e plus 1. If we have 2 times this whole term, then we have to times this by 2 as well. Expanding this bracket, think of the 2 on its own as being 2 over 1. So 2 over 1 times 1 over e gives us 2 over e. 2 over 1 times 1 gives us 2. Writing this first, this part now is ln of 2 plus 2 over e. And finally, to get t on its own, we divide by 0.2. It might be easier to see that 0.2 is equal to 1/5. So if we have 1/5 t equals this, to get rid of 1/5 we can just times both sides by 5. So the final answer is t equals 5 ln 2 plus 2 over e. So our a is equal to 5 and our b is equal to 2.